When we do these problems, we're going to need to know the identity and or quantity of the gas involved in the chemical reaction. So we might have to or need to calculate the volumes of gases consumed or produced in the reaction. And we kind of, the one that I did with you yesterday kind of uses this whole principle. I used it, but we hadn't talked about this. So you can use your, we have to think about the mole concept and how it applies to a chemical reaction. So we have to be sure that we write the equation. We have to have the equation, and we have to balance the equation. And then we can use our stoichiometric equivalencies like we've done previously to allow us to solve problems. I think I gave you an example on here. Yeah, let's look at the back of that page that we just did the problem on. I thought I put that on there. Automobile airbags are inflated by nitrogen gas generated by the decomposition, if you've ever been hit by an airbag, you know it happens fast, of sodium azide. If an airbag has a volume of 36 liters and is to be filled with nitrogen gas at 1.15 atmospheres and 26 degrees Celsius, how many grams of sodium azide are required to decompose? And I gave you the formula for that because that's something we hadn't had before. So the first thing you're going to do is make your conversions. It's always the place you want to start. So it's nice, we have atmospheres already, we just have our one temperature conversion to make. So I've got 273 plus, what was it, 26. Is that 299K? Okay, then the second thing you want to do with one of these is write the equation. Or I'm going to say write the balanced equation. So take a minute and do that with the information you have in the problem. See if you can write the equation. When you have the balanced equation, stand up when you think you have it. Okay, Luke and Kira check with each other. See if you have the same thing, and then those three can check with each other. Or four. Oh, Kira, you over there and check with them. I didn't see you. Okay, so what kind of a reaction is this of the 5 major reactions? Remember, you got synthesis, decomposition, single replacement, double replacement, combustion. Which one is it? It's a decomposition reaction because I start with the sodium azide, which I gave you the formula for. So that is NaN3, and it would be in solid form. And it's going to break down. And it said it fills up with nitrogen gas, so I know I have N2 gas plus, what's the only thing that I can also have? Sodium, plus sodium. And that sodium's in a solid form. It's sort of like a powder. When you get that on you, it burns. If you've ever seen anybody that's been hit by an airbag, they usually have burns and bruises. It's not a pleasant experience. So then you have to balance it. So we have to put a 2 there, a 2 there, and a 3 here. So now I've got my stoichiometric equivalencies set up with my balanced equation. And then the next thing I'm going to do is, we need to determine